Hi, this is Carl with another version of my demonstration of the the PRT network that I've drawn using the new simulator made available to the general public by Ultra PRT. I've added some new efficiencies. I've labeled the stations now to something a little bit more appropriate. Added some extra shortcuts. The shortcuts exist essentially so that you can bypass whole swaths of the network if you're not needing to stop at any of the stations in a particular quadrant. So as you can see, there's a shortcut here, another one here to get you up to the University LRT, another one here bypassing Brentwood, another one here bypassing the Olympic Oval to get to Market Mall faster and points beyond, and so on and so forth. I'm just going to actually run the simulation now so you can actually see it in action. The green dots indicate PRT pods that are actually full of passengers, or at least one passenger going to a destination. The red pods indicate empty pods, or the red dots indicate empty pods that are either on their way back to a depot because they're no longer needed at this particular moment, or they're on their way from a depot or another station to a station that needs to fulfill the need of a passenger or a group of passengers that need to get from one station to another. The numbers on the stations indicate how many people in that station are currently waiting for a pod to arrive to get them on their way to the next trip. And the circles within the stations themselves are indicating the status of each of the berths that the station has. So as you can see, some stations only have 2 berths, some have 3, some are high capacity stations and have more berths. Like, for example, the LRT stations that I created have 5 berths. The berth colors, very specific. Red means there is a PRT pod parked, empty in that berth, waiting to be used. Green means it's loading. Blue means it's unloading. Gray means it's waiting for its chance to get onto the track and join the rest of the traffic. And white means the berth is essentially empty, which would indicate why there's numbers, increasingly large numbers, eventually showing up in the station indicator. So this is a really good indicator of the function working. I don't remember if I mentioned the depots or not, but essentially the depots are holding areas for empty cars so that as the network demand starts to pick up, if the station just can't meet the demand of people waiting for a pod to come and take them to their destination, then the depot spits out red empty pods to meet the demands of the station downstream. And of course, if there ends up being too many empty pods on the network, they park themselves back into a depot to recharge themselves or wait for the demand to pick up again. So really, really cool simulation. When you are done running the simulation, you can start looking at things like average wait time at the various stations. So for example, right now I have a very high degree of percentage of trip waits that took less than 60 seconds. In some cases, every trip was able to get on a pod in less than 60 seconds. Here I'm showing network distance between stations in kilometers. And the most important statistic, I think, that this simulator produces automatically, which is amazing, is the actual trip time between stations. So this is telling. Alberta Children's Hospital to Banff Trail LRT, 303 seconds. Foothills Medical Center to Banff Trail LRT, 171 seconds. Market Mall to Foothills Medical Center, 345 seconds. Try doing that with a bus in Calgary's current transit situation. It can't be done. It just can't be done. This, my friends, is the magic of PRT.